All right, here we're looking at section 10.7, and our learning targets for today, we're going to be writing and graphing equations of circles. Then we're going to write coordinate proofs involving circles, and then solve some real-life problems using graphs of circles. So now we're just taking all that information about circles and putting them on the coordinate plane and looking at the equations of them on that coordinate plane. So here's the standard equation of a circle. So xy is any point on that circle, and my center is going to be h comma k. So h is going to be my x value of my center, and k is going to be the y value of my center. And r is the radius length. So here's the standard equation of a circle. So I've got x minus h. That's the big thing. It's always going to be minus in between here. So x minus h squared plus y minus k squared equals r squared. And that r is always my radius. So the big things I need to know when dealing with the equation of my circle is my center is at hk and the radius is r. So now let's look at this first example. So write the standard equation of each circle. So first let's look at the circle shown at the left. So the first thing I want to do is I want to find the center of my circle, which I see is at 0, 0. It's my origin. And I also need to find the radius. So my radius of this circle is 3. So now based on that, I can write my standard equation. So I've got x minus h squared plus y minus k squared equals r squared. So I substitute in my values that I found for the center and my radius, and I simplify. So the equation of this circle is x squared plus y squared equals 9. So let's look at part B. I have a circle with a center at 0, negative 9, and a radius of 4.2. So again, I can just write my standard equation, which is x minus h squared plus y minus k squared equals r squared. Substitute the things that I know. And it's always really important when I substitute the values that I know that I use parentheses. So I've got x minus 0 squared plus y minus a negative 9 squared equals 4.2 squared. So then I can simplify. So I end up with y plus 9 squared. And so my standard equation is going to be x squared plus quote the quantity y plus 9 squared equals 17.64. So here are some for you to try. I really want you to look at what would you do if the center is not at the origin. So now let's look at this circle. So the point negative 5, 6 is on a circle with center negative 1, 3. Write the standard equation of the circle. So the things I need, again, for my standard equation, I need the center, which I have here, and I need the radius of my circle, which I don't have yet. But I do have a point that lies on my circle. So I can use that point and the center and use my distance formula to find the radius length of my circle. Okay, so let's do that first. Here's my distance formula, right? And I use my 2 points, my center and my point negative 5, 6. So I use my distance formula to kind of continue and simplify, to find that the radius of this circle is 5. So now that I have the center and the radius, I can go ahead and write my equation and substitute the things that I know using the points that I had for the center and my radius, and then I simplify. So my standard equation is x plus 1 squared plus y minus 3 squared equals 25. So now here I see I'm given this equation, but it's in a little bit different form. So here's my equation, x squared plus y squared minus 8x plus 4y minus 16 equals 0. So from this, I'm supposed to find the center and the radius and then graph it. So the first thing I want to do is I want to get this written in the way that I have seen it before, into my standard form of a circle. Okay, so I want to complete the square. So here's where we're going to take several steps to do this. So the first thing I do is I rewrite my equation. Then I isolate my constant, and the constant is the thing that's by itself. So get the thing that's by itself, right? I don't have any variables over by its own on its own side. So then I complete the square. So let me go ahead and put some colors here. What I'm looking at is I'm looking at my x squared minus 8x, and I'm looking at my y squared plus 4y. So to complete the square for this, I take my b term, right? And my b term is anything with my x, not with the squared, but with the single variable. And I divide it by 2, and then I square it. Okay, so I took my negative 8 divided by 2, which was negative 4, and I squared it, which gave me 16. But when I add this 16 to one side, I have to add it to the other side. So that's where that is over here. So now I do the same thing with my y's. I take the value that's with my just plain y, I divide it by 2, which is 2, and I square it, which gives me 4. So I add that again to both sides. So now that I've done this, I can actually complete the square. So now I'm just looking at the x's. So I want to just simplify and complete the square for my x's. So I end up with x minus 4 squared. And I got this minus 4. This minus 4 is this b divided by 2. It's the, before I squared it, it's the thing that goes in here. So again here, 4 divided by 2 is 2. So that goes in there. So I've got my x minus 4 squared plus y plus 2 squared equals 36. So now I've completely simplified all my sides. So now I can rewrite my equation with negatives in here, right? Because it's always x minus and y minus. So now I can find the center and the radius. So my center is 4 comma negative 2, and the radius is 6. So then I can use a compass to graph my circle. So I plot my point, my very center of my compass at 4, negative 2, and I make sure that my radius is 6, and then I can just graph it from there. So that's what my circle looks like. So now here are a few that I want you to try. Now these are very important steps that you need to be able to do, so I want you to work on both of these problems. So now here's our proof, right? Now we have to prove or disprove that the point the square root of 2 lies on the circle centered at the origin and containing the point 2 comma 0. So the first thing that I would do is I would draw myself a little sketch, right? So I've got my coordinate plane. My circle is at the center, and it contains the point 2 comma 0. So I know that my radius is right here, so it's going to be something kind of like this. Okay, just so I have a visual of what I'm actually kind of looking at. So there's that. I can see that my radius, the distance from the center to a point, is 2, and I used the distance formula here. Okay, so a point lies on the circle if and only if the distance from that point to the origin is 2. So now I can use my distance formula again and see that if is my distance from this point to this point 2, because I found that my radius was 2. So if I just use my distance formula and I come up with 2, then I can say yes. If I use my distance formula and this is something other than the radius of the circle, I would say no. But since it was 2, I can say that yes, that point lies on my circle. So now here's one for you to try, kind of similar to what we just did. So go ahead and you're going to use the distance formula to see if your radius is the same length. So now let's look at a real world problem. We really use circles a lot and graphing circles when we're dealing with earthquakes. So the epicenter of an earthquake is the point on Earth's surface directly above the earthquake's origin. A seismograph can be used to determine the distance to the epicenter of an earthquake. Seismographs are needed in 3 places to locate an earthquake's epicenter. Use the seismograph readings from locations A, B, and C to find the epicenter of an earthquake. Okay, so now here we go. The epicenter is 7 miles away from this point. The epicenter is 4 miles away from this point, and the epicenter is 5 miles away from this point. So let's go ahead and set them all equidistant to a given point. So I want to go ahead and first draw out my 3 circles. So I have a circle with a center at negative 2 comma 2.5 and a radius of 7. I have a circle with a center of 4 comma 6 and a radius of 4. And I have another circle with its center at 3 comma negative 2.5 and a radius of 5. So I know that where these 3 circles meet is going to be where my epicenter is. So I graph these circles and see where they meet. So I've graphed all 3 of my circles and I see that they all come to meet at this point right here, which is about 5 comma 2. Okay, so I first look at all of my different circles and I see where they meet. So now I want you to think about this one for a minute. So why do I need 3 seismographs and not just 2? Why would 2 not give me the information that I need? So let's look back at our learning targets. First, we had to write and graph equations of circles. This big one is definitely if we go from the original form we're given into standard form. We have to know how to complete the square to get the equations so that we can actually find the center and the radius. Then we looked at some coordinate proofs involving circles. And finally, we looked at some real-life problems using graphs of circles. So now I want you to go ahead and work on your homework for 10.7.